Okay, last page of the notes. I'm going to skip the monitoring progress. You guys can do those and check answers with the Big Ideas ebook if you want to. I'm going to jump into the real life problem in example number 6. So we have a penny that is thrown straight down from a height of 200 feet. At the very same time, a paintbrush is dropped from a height of 100 feet. The polynomials over here, there are 2 of them, represent the height of the objects after t seconds. The top one must be the penny because it was dropped from a higher height than the paintbrush. So the penny is the top one, the brush is the bottom one. What we're going to do is, and I should mention that these are the actual formulas that would be in effect if you threw that penny downward. You actually gave it an initial velocity of 40 feet per second and you just dropped the hairbrush. Those are the actual formulas that would use to do some calculations. Maybe figure out how long it took them to hit the ground or whatever. Okay, so we're going to do part A where we write a polynomial that represents the distance between the penny and the paintbrush. Well, we really just need to subtract because the distance between them is going to be the difference between their heights. So we're going to take the larger number, which is going to, at least at the start, be the penny. We're going to take that polynomial and we're going to subtract the lower value, the lower height, and that's going to give us the distance between the two. So we're just going to do this horizontally. I'm going to remove the first set of parentheses. They're just there to group the terms together and nothing else. But the second set of parentheses, remember we have to distribute the negative. So we're going to do the negative of negative 16t squared. So it's like we're multiplying through with a negative 1. So that becomes a plus 16t squared. And then the negative times the positive 100 is negative 100. Okay, I'm going to reorder things just a little bit. Negative 16t squared plus 16t squared. Do you notice those two are going to add up to 0? Don't lose anybody. We're just reordering. Those two, the negative 16t squared and the 16t squared, add up to 0. So I will just not write anything there. Negative 40t doesn't have any like terms to combine with it. And then the positive 200 and the negative 100 add up to positive 100. And that's our answer to part A. That's a polynomial that would calculate the distance between the penny and the paintbrush. Now in part B, we're supposed to interpret the coefficients of the polynomial. And I'm going to start with the 100 because it's a little easier. So when t equals 0, we have 100, right? And what that 100 means is when they are initially dropped, when the two things are initially dropped, it is 100 feet between the objects, or 100 feet between them at the start of this little experiment, right? That's what that means. 100 feet between them at the start. Okay? Now the negative 40. So what I want you to look at is that slope. Notice that's a linear function. That's really y equals mx plus b. 100 is the start value. 100 feet between them at the start. The negative 40 is negative 40 over 1. What that means is every time the time increases by 1 second, the distance between the objects goes down by 40 feet. So we can interpret the answer to part B using our knowledge of slope and y-intercept. So every second, what that negative 40 means is every second the distance between the objects goes down by 40 feet, or decreases. Every second the distance between the objects, I'll put a thought in there, distance between the objects decreases by 40 feet. Another way of saying it is every second they get 40 feet closer together.